Hello and welcome back to my C++ libraries video series. In this video series, we're going to take a look at a new C++ library every week. Now in today's week, we're going to take a look at spdlog, a fast C++ logging library. And yeah, that describes spdlog quite well because spdlog's purpose is to write log messages. And general idea of a logging library is you have a function that you're going to call if something occurs in your application, if a debug message shall be occurred, if a error condition occurred, a warning condition occurred, or anything else. Really, in general, it doesn't matter. If something occurs in your program, you're gonna wanna write a log message. And the logging library takes this log message and processes this log messages. It can most of the time send this to one or multiple loggers, which then in turn is gonna format the message, filtering the message, and then at some point gonna output them to something in spdlog. It's called a logging sync. And the logging sync's purpose is then to kind of like display or output a logging message. For example, a logging sync could output the log message to a console so that you can see what's going on. A logging sync could output the logging message to a file, or it could output it to a syslog server. So it could be a syslog client and send the message to a syslog server. So really you have many options when it comes to logging in C++. And spdlog is a library, and my personal favorite library, which does everything that you need. Now if you take a look at this down here, you can actually see all the features that it really has. It's fast, header only or compiled, feature rich by using FMT. Last week we talked about FMT. In today's we're going to talk about spdlog because spdlog is building on top of FMT. So all log messages that we're going to output are actually FMT format strings. And the nice thing is, if it is an FMT message, you can really do formatting as you like. It supports asynchronous mode, custom formatting, multi-single-threaded logger, various log targets, so rotating log files, daily log files, console logging, syslog, Windows event log, Windows debugger, and your own custom stuff, as I already told you. It supports log filtering, both at compile and runtime, so they have some logging macros, and if you are using the logging macros, you can kind of like filter the log messages on compile time and basically compile out, debug, and trace messages on a release build, for example. But you can also have them at runtime log messages there as well, which is what I would recommend for business applications, that you have them selectable at runtime. So if any user encounters an issue, you can basically tell them, all right, start the application, go to the settings, enable extensive logging, and then send me the log files, and then you can see what's going wrong. If you're writing a game, then of course you don't want to have too much logging because logging also costs performance, and you want to have them optimized away compile time. So really it supports everything that you want, including features like backtrace, which allows you to kind of like hold back log messages that would normally not be displayed, for example, like debug log messages. And as soon as an error occurs, you can do like a backtrace, and it shows like the last, like let's say 20 debug log messages, so you really see what's going on. Alright, so that's it for the short description on spdlog. Let's actually try it out and play a bit around with it. Now, spdlog can be downloaded here as a release, which probably gives you a nice package here. Now it just gives you the raw source code, which I would recommend then compiling with CMake. However, what we use in this tutorial series is we are using a package manager. We are using the package manager Conan, and you can see that Conan also features spdlog in the latest version here. It's under conan.io center spdlog, and the token is spdlog/the version, so 1.11.0, which is also fitting with the one in here. And if you take a look at this, it's actually it's supporting Conan here. So Conan is officially supported by spdlog. Alright, so what I have already prepared is a copy of my moxpp template. Moxpp is a GitHub template repository for Conan 2 and Premake 5. So Premake 5 is a build system generating Visual Studio solutions or on Linux makefiles, and is my build system of choice. And I have written a template here, a template repository that basically gets you started with Conan and Premake 5, and you can get to market fast. And this is what I want to show. The first thing that you need to do is you need to open up the Conan file. The Conan file defines all the requirements. You can see that I've already have spdlog in here. This is because the moxpp template comes with spdlog as an example. So what you need to do to get spdlog, you need to call the self.requires function with the token in here, the token that we get from the Conan Center, inside the dev requirements self function here inside of the Conan file.py. Now adding this here basically enables spdlog for our project. Now what I want to do is a bit of customization. I'm going to do the customization in 2 places. Mox.lua is a general customization. I'm going to call this one spdlog because I want to kind of like explore spdlog. And then what I also want to change is the project name. The project name is in source build.lua. In this case, it's currently called hello world. I'm just going to replace this with spdlog log example. I always append the underscore example. It's important that you're not going to name is the same than the library, because then you're going to have linking issues if 2 projects are named the same. So our main project and our library, if they have the same name, we don't know where to link to. So it's important that they have different names. Now, as soon as I'm done, I can invoke and create the Visual Studio solution. The Visual Studio solution is by entering mox init in the normal CMD on Windows. Mox init is going to initialize everything, downloading spdlog, maybe compiling it if it is not already compiled, and at some point it generates you a solution, spdlog.sln. I can open this up by just typing in spdlog.sln in the console, and it's going to open up Visual Studio with our solution. All right, there we go. Inside the spdlog solution, we have the spdlog example project with a main.cpp, and instead of main.cpp, we already have a bit of spdlog in here, because by default, moxpp comes with spdlog integrated to say hello world, so that the normal moxpp kind of like initial template shows you that library management works by downloading the logging library. And since I, at least on business application, at least I always use spdlog, it's always a good starting point to have it in here, because every project needs a logging system, really, every big project. All right, so spdlog is included by one main include, spdlog.h, that's the include that we need, and as soon as this log is in, or this include is in here, we can use spdlog. Now, how do we use spdlog? Well, I want to start simple. So the simplest way of using it is by going into the spdlog namespace and calling some logging functions that are directly bounded in here. Now, spdlog does have an advanced concept of like loggers, logger registries, sinks, and a lot of complicated setup that you can do, but by default, spdlog is already configured so that you can use it. So by default, what you can do is you can call a function directly on the spdlog namespace. There are multiple functions of it. The first one is still function trace, which emits a log message of the server trace. So this is kind of like, I think it's 0 trace. I don't know what it is, but this is kind of like log level trace. This is kind of like what this is doing, and what spdlog has is it has multiple log levels, so it's not only going to have trace, it's going to have trace, debug, info, then it's going to have warn, and it has error, which I of course need to call error, and it has something called critical. These are the kind of like servities that we have, critical, several log levels, and they are in exact that order. So trace is kind of like the lowest severity of error message, and critical is the most high level of critical of error message. And yeah, as soon as we have kind of like emitted all these functions, we can hit a 5 and see what we got. So if I basically all call them and run them, you're gonna get the following output: info, warning, error, critical, info, warn, error, critical. So you can see that logging seems to work. However, it also seems to not work, because we only get info, warn, and error and critical. And this is because of the log level. By default, the default logger inside of spdlog is configured to only show info messages and messages with a higher severity or a higher log level. So by default, trace and debug messages are now never going to be shown by spdlog. To show them, we need to reconfigure the logger, and we need to set the log level. Now, of course, you can go and do some custom setup with a custom logger. However, what you can also do is you can get access to the default layer logger from spdlog and then reconfigure the default logger. So what I can say is I can call the function default logger here, so spdlog default logger, which gives me a shared pointer to the default logger. And what I can then do is I can call the function set level to set a new log level of spdlog. So spdlog level, no, just level. It's a bit buggy here. You always need to kind of like manually do this. I don't know why Visual Studio is doing that. However, you can do spdlog level and then set the log level that you want to set. In our case, I want to show trace messages. So what I can say is I can say spdlog level trace, and if I set the level of the default level to logger to trace, it will emit all messages. So now you can see we get trace, debug info, warn, error, and critical. Of course, it also works in a different way. I can also say that I just want to have like error messages. So everything that's kind of like not a normal condition, which would be warning, error, and critical. And you can see it's directly reflecting our behavior and directly showing us exactly what we need. All right, so that's basically the general usage of spdlog. What I want to do now is I want to go more into the detail on how loggers really work. Now, to show you how they work, I want to quickly show you how the implementation of these default functions work. So by default, what spdlog trace is going to do, it is not going to call spdlog trace. Actually, what spdlog trace is going to do, we can maybe even take a look in it, is it is actually calling the trace message on the default logger raw. So all of these messages or all these calls are basically going to the default logger, and the default logger is then gonna issue raw and or is gonna issue the kind of like debug or warn levels. Now the default logger raw is a bit more convoluted, but it is basically getting the default logger at some point and it's getting the pointer from it. So this is a shared pointer, and this is kind of like the get function. So get default logger and get default logger raw are not really any different. One of them is gaining access to the shared pointer. The other one is gaining access to the kind of like raw C++ pointer. But the raw C++ pointer is kind of like derivated from a shared pointer. So I don't see the point in calling the raw function actually. Because if spdlog wants to always use shared pointers, which it does, we always want to use them as well. So instead of like calling this main namespace, we can replace it with a call to spdlog default logger trace. So this is actually a way of doing it. We can get the default logger and then we can call trace on it. And if we are running it like that, you're gonna see that it's still gonna perform the same way. Maybe let's put this to debug now. Okay. It's gonna perform the same way. It's gonna output the error message depending on the log levels, and it's all good. Now, actually, trace, debug, info, warn, error, and critical are also a lie. These messages are a lie. They are actually not proper messages. If I would peek in here, you can actually see that trace is just an alias call to log with the level trace. So what we can do is we can even replace this even further to the default log function and provide a level trace here. And we can continue this on. Let's quickly copy and paste them, and then I'm gonna adjust these. And then now my comments are also redundant, because now you can actually see what's going on. And what you can see now is that we are now actually calling one log message that is then gonna take kind of like the kind of like log level that we have. So info, warn, error, which is actually just called error, and critical. And if I do it like that, it's going to do the same thing that we always had previously. It is going to give us all of our log messages exactly as we have them. However, what we can see now is that it is doing, we can actually see a bit more what it is doing. So in general, what it is doing, it is getting a logger and it's calling the log function on it with a level. So this kind of like gives us a bit more information on what's going on. We set the level on the logger and then we log, and based on the level, the logger, in this case the default logger, is doing its filtering. So now what I want to do is I want to replace the default logger with my own custom logger. So how do I create a custom logger? Well, what we want to do is we want to have a std shared pointer of a spdlog logger. This is what we want to have. So a shared pointer to a spdlog logger. Let's call this one my logger, and let's set this equal to std make shared of spdlog logger. So we can create a normal new logger by constructing one like that. Now the logger shall always get a default parameter. So you shall never create a logger like that. It might work, right? Let's see. Can we create a logger like that, or does it even not compile? Not quite sure of that actually. No, it doesn't even compile because it can't find a constructor for that. The problem with std make shared is that you don't get any error information. Basically, it does not find a implementation of the constructor which takes no parameters. Actually, what every logger needs is a name. So as soon as you're creating a logger, you should give it a name. If I make the name empty, it might work. It's probably gonna work because it's an empty string. There you go. Now I have my own custom logger. However, you shall always give them a name. And since we called this one my logger, let's call this one my logger here as well. And now we have our own custom logger that we can now use instead of the default logger. So my logger, we can use it here. At least if I could type it correctly. There we go. Now we have the my logger, and I can basically replace all of the log calls to the calls to my logger and run the application, and we have log to our custom logger. However, you can see that our custom logger has not outputted anything, and of course it hasn't outputted anything because the logger has no logging sinks attached, and the logging sink is kind of like the unit that's responsible for displaying the message, for processing the message. Now we have kind of like a container that we can configure. We can set the level, we can set the pattern, we can do many things with the logger, but the logger has no targets where it logs to. To create a logging target, we need to configure a sink. So what I can do is I can call the sinks function on here. If I call the sinks function, I get the sinks, I gain access to the sinks. It's an std vector of spdlog sync pointers, and sync pointers are shared pointer to spdlog syncs. And what I can do is I can call the pushback function and add a new sync to that. Now syncs are all managed in their own header file. So for example, if I want to output to the console, like we did it previously, I can go and search myself a sync caller. So it's actually called stdout. stdout colorsinks.h is what we want to care about. We have the stdout things, which are the normal stdout things, and we have the color sinks, which are the things that can actually display color in the console. I want to have them with colors. So let's create a new one, make shared of spdlog sinks, and then we have a stdout color sync empty and a std color sync st. St stands for single threaded and empty stands for multi-threaded. I'm just going to use multi-threaded here. You could also say st if you know that just one thread will access it, would also work. And we can just default construct one of these syncs and everything is good. But I'm going to take the multi-threaded version here. Or not, I don't know. You should probably rather stick to creating multi-threaded ones instead of single-threaded ones. Yeah, and as soon as I do it, we get output. The output actually looks a bit different because now the logger name is also incorporated. So now the logger name is in here, my logger, and then we have like debug info. spdlog is on the default logger, configuring the logger a bit different, which does not include the logger name. However, what we want to do, we want to have actually the logger name. So if we have multiple loggers from multiple subsystems, we know what's going on because they can all like output to their own sync. You could create like a console sync, one single console sync, a multi-threaded one. So like an auto console sync, you could create that one by creating that one and maybe make it multi-threaded. And every thread is then gonna get a reference to that console sync. This is something that you can do. You create like one console sync, one like error log file, and one kind of like normal log file. And then you're going to attach them to all of your loggers. And each logger is a single-threaded logger, but they all access the same things, which are then multi-threaded. So you kind of like serialize them all inside of like one sync, multiple loggers. This all works with spdlog. And of course, we want to, of course, use more things than just that colored sync. We want to also use now a file output so that I can show you to that. And the file output is actually called basic file sync if you just want to have a basic file sync, which is exactly what we want to have here. So I can create a basic file sync. Let's call this one error log file sync, so an error log file where we only want to have error messages, and then we can use the other thing, basic file sync empty for multi-threaded. Then I want to have a debug log file sync, so I want to have a logging file that gets debug messages and one that only gets error messages. So yeah, basically warn and more, and the other one is going to get debug and more. That's kind of like the idea. And what we do is we want to attach them, of course, all to the logger that we have created, and I think this should not compile because we have not specified a logging file here. No appropriate default constructors available because a basic file needs a file where it shall log to, and I want to have an error.log, and I want to have a debug.log file where I want to log to. Error log, debug log, the logger is created, attached to it, then the logger is configured, and then we can call the log functions. And if I run that, I would suspect that I get log files. So we get the output here, debug, info, warning, error, critical, and we shall also get the log files. Now to see the log files, I'm going to open up Visual Studio Code and open up the app directory, because the app directory is the working directory of our application configured by moxpp. And you can see that we have two files. We have a debug.log and a error.log. However, if we're taking a look at this, both of these things have the same input. Or the same content. So that's not what we want. Let's delete them and let's retry it. Now the thing is that you can actually configure things. Things can be configured the same way than loggers, and you can actually, by default, everything is configured to display all log messages. What you can do is you can configure the levels of the sync actually. So I can get a level here, and I think there should also be a set level function. Yeah, a set level function, and then I can set a new level for that sync. So for example, the error file sync shall only take the ones for warnings, and this shall only take ones for debug, the debug sync. Now that they are both configured, now the console should get every log message. The debug file should only get debug and more messages, and the error log file shall only get warning and more critical messages. Now, first of all, I want to reconfigure my logger so that my logger displays everything, because first of all, the logger is there for filtering. So as soon as you're calling a function, the logger is first checked if the filter is matching. So if trace is not inside kind of like the range of the logger, it's not even sent to the sinks. And after that, the sinks can kind of like come here and perform their filtering operations. So what I would now suspect that I get all messages in the console, all these ones in my debug.log, and all these ones in my error.log. That's kind of like the thing that I would suspect now to get. Let's press F5 and see if we get it. All right, we get all messages inside the console. If we are going inside of Visual Studio Code, we have an error.log that only gets warning, error, and critical. And we have a debug.log that gets debug, info, warning, error, and critical, but not our trace messages, because all the trace messages were in the console as well. So now we have actually very quickly configured ourselves a nice little logging environment. Now what we can do now is we even can customize this a bit more. What I personally tend to do is also configure the pattern of the logger, because I don't like how spdlog prints these messages, right? They are not really readable. I want to have the level at the left, then I want to have the name of the logger, and then I want to have the timestamp, or maybe I want to have the timestamp first, then the level, then the name. So you can really configure it how you like. And to see how you can configure that, in the wiki they have a custom formatting article, and if you scroll a bit down, you can find so-called pattern flags that you can use to display the log messages. For example, the actual text of the log messages are %v. So if I would want to configure my logger, I can set the pattern and provide a string here. If I would just provide the %v, we would just get the actual text of the messages. And if I do it like that, yeah, there you go. We just get our text messages. Same goes for the files. The files are pending, by the way. You can see we only get the text messages, no more information around that. Now, what I do is I tend to format my dates how they are in Germany. So day of month, and 4-digit year. So kind of like %d, %m, %y. So %d dot %m %y. This is kind of like my date format in Germany. And then we have the hour format. The hour format is already defined here. So the ISO time format, HMS, which is %t for ISO time. %t, let's put this in here. And now I would suspect that I also get the date and the time in here, and then a double point, and then the log message. And there you go. Trace, debug, info, warn, error, critical. Same goes for the files. It's formatted globally, and the files just appended there as well. Now, of course, what I want to have is I want to have the log level, and I like that they are putting it in these square brackets, so I want to keep that convention. Now the square brackets, and then I want to have the log level. The log level is, if I scroll a bit up, the log level is %L, or what I can also use is a big percentage and then a big L for the short version. And I think the short version is sufficient, so let's %L in here to get the kind of like servity of the message. And if I run it, I would suspect that we are getting TDIWEC. Yeah. Trace, debug, info, warn, error, critical. Now, of course, they are not colored here because color is needs to be in the pattern there as well. And if we are scrolling down there, you can at some point actually see how we're going to do color, start color range and end color range. So percentage, yeah, kind of like this power sign, and $dollar is to stop it again. So let's put it in here. Let's say start the color here. And percentage dollar sign percentage dollar sign like that means end the color range. And if I run it, we get our color back. That's amazing. Now, what I also want to do is I want to have the name of the logger. This was something that was also quite useful. So kind of like the domain where we are logging. Also want to put it in these brackets here. And if I scroll a bit around and see where I get this, I think logger name should begin somewhere up here. So the logger's name, %N. So let's do %N here for name. And if I run it, we shall get the logger name back. And there we go, my logger, trace, debug, info, warn, error, critical in my custom format. It is all the same on the file system. By the way, Visual Studio Code tries to do some highlighting here. However, the files for this are of course not colored because it's just a normal text file. But Visual Studio tries to do some fancy stuff, whatever. But yeah. So yeah, you can see that we can tinker a hell lot around with it and use them. However, there's now one big problem that we have, and the problem is called logger management. Now, how do we manage our logger? Do we really need to pass the logger to every function that shall use logging or shall use a special logger that's not the default logger? No, we can register our logger. There are multiple ways of registering our logger. We can register a default logger. So I can actually say set default logger, and if I say set default logger and put in the my logger here, we now have a new default logger. And if I would do this, so spdlog log, so the normal log function, which automatically uses the default logger, I could now use trace, debug, info, warn, error, and critical again, the direct functions, but I'm too lazy to replace them. Now, as soon as I set my logger as the default logger, it's automatically going to redirect all these messages to my logger. And it's all good. So you can see now I'm using the default logger, but I'm still kind of like at the end going to kind of like the logger called my logger. And now it would be kind of like making sense to morely like call this one main as a logger name. And if I run it, I shall now get the messages from my main logger here. So there it is. And it's all nice and simple. Now, what I now want to do is I want to create a debug logger that's only going to be there for debug messages, that is not going to be backed by the files. So let's create a new logger, debug, and let's add the console sync to the logger. So debug logger, and let's configure the sync in here. I do want to have the same formats here, so I'm going to call these ones the same. And there we go. So now we have the my logger and we have the debug logger. And what I want to do is I want to now also log to the debug logger, but I want to log it with kind of like the normal function here, or a normal function here, without kind of like gaining access to the debug logger, so without calling debug logger. But this currently doesn't work, right? If I run this, it shouldn't change anything on the other code. But what I want to do is I now want to call something on the debug logger, but without using the debug logger's kind of like pointer. Now, how do I do that? Well, I'm going to register the debug logger. So there's a function called register logger, and the register logger function is going to register a logger by its name. So if I register the logger, debug logger, I can now access it by its name. And I can basically say get here, which is getting in your logger from spdlog, in this case debug, and then I can say, for example, it's a shared pointer, warn, this is console only. So now we have a message that's console only. Just to see this a bit better, I'm going to quickly delete my files, go back to Visual Studio, and now I should get like one log message more. In the console, they shall all be printed, and the last one shall not be on the main, it shall be on the debug one. This is console only. And if I go into my files and I go to my error.log, you can see that there's only the warnings for the main logger. In here are also just the messages for the main logger, but there's no message for the debug logger because the debug logger just got the console sync, but not the file sync. So what you can do is basically by calling register logger, register these loggers and get them with spdlog get. Of course, there are also different ways, right? You can also could also write a class like class loggable. Something that you could write, and then the class loggable could have a spdlog logger. In this case, std shared pointer to a logger. And what you can do or could do, for example, is you could kind of like have a constructor with an std string view here, and then you could say something like spdlog get sv, and then assign this to the logger. And then you could kind of like cache them, for example. You could also directly pass in these if they are not registered with the registry. You could also say, all right, they shall also be passable by the pointer. So something like that, logger. And then you say, now they are called the same, this logger equals logger. This is something that you could do as well. You could copy loggers around. So kind of like from a const loggable other, you could say something like other logger and copy him over. So really you have many options on how you could do log management. This is probably how I would do it nowadays. I would kind of like create myself a base class loggable that can be like copied around from other loggers, created by a string, a shared pointer, or maybe even a constructor that takes a new logger or the parameters for a new logger that then are registered, because this basically allows you to write nice classes like class my module could be based on loggable, for example, public, private. Yeah, let's make it public loggable, and maybe make that one protected so that we can even access the logger. And then inside of the constructor I would do something like loggable debug if I want to have access to the main to the constructor. So loggable to call the constructor, and yeah, let's maybe add a bit of a call in here. So logger info hello. I could do something like that, and then if I kind of like create my module down here, it shall automatically configure its own logger internally. This is something that's just a way of thinking on how this could work, right? Now you have the logger hello. And if my module creates a submodule, which is also a loggable, let's quickly public using loggable here so that we can access to the constructor. And if I create like a submodule sub, I could create this from this because it's a loggable. Is it or is it not? Const loggable reference other. This should actually work. Or I could just say logger and pass the logger on. This is kind of like the idea, so that you have multiple ways of gaining access to the loggers. But it's just a bit of more information that you probably didn't want to hear. But maybe yes. I think it's kind of like a useful construct, my loggable here, so that you have a bit of access to how you can access and create loggers. Of course, they all need to be registered, right? Of course. But we could also go even more nuts and provide like an std function that is going to create the logger, and then it's going to be registered, and you can go nuts. But you don't need to. That depends on how your framework is going to be built up. But this is kind of like a basic introduction to spdlog. Maybe a bit longer than I intended it to be, but I think spdlog is a very important and also a very good library that's actually justifying a long video about it. All right, so thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.